Chapter 6, Test A. Review. Find the radian measure of 72 degrees. Find the radian from degrees by multiplying by
180.
pi over 180. You want radians, so the radian goes on top. All right, and then you reduce. Reduce by 9, that gives me 8 and 20. Reduce by 4, 2 pi over 5. Find the degree. Multiply by what? You want the degree, so the degree goes on top. Pi cancels. Reduce the 2 and the 180. You get negative 270. But you should have known that because pi over 2 is 90. Negative 3 times 90 is negative 270.
You say you reduced 180 by 2?
Yeah.
Depends on the 90 or?
Yeah, it's a 90. Okay. There's no number 3 on here. We had deleted a number, so tell me what the area of the shaded sector formula is, because I don't know it.
Is it the area equals 1/2 r squared theta times pi over 180? Is that right?
R squared theta. Yeah, so theta has to be in terms of radians. So we have 1/2. The radius is 5. What's your degree?
140.
No, it's not.
The shaded area.
Shaded area, which is?
360 minus 120.
40?
Okay.
Yeah, let's see if you can figure that out, please. Go ahead and figure it out. 47.997. Take 220 times pi first, then divide by 180, then multiply it by 25, and then divide by 2. I mean, you can do it the other way, but it's easier to do it that way on your calculator. Good? Yep. You're putting in the wrong number somehow. All right, now, find exact values of theta. So you have theta. This is practice A. On practice B test, there is no theta on number 4. Put it at the top corner. The top corner between 12 and 13.
SohCahToa.
All right.
What'd you say, please?
Top corner.
Between the 12 and 13. Theta. On practice B. Okay, come on. So now we're at theta here. Sine for SohCahToa.
3/5.
Problem number 4.
Sine is opposite over hypotenuse. Opposite of theta is 3 over hypotenuse 5. So 3/5. Cosine is the adjacent leg. The adjacent leg is 4. Hypotenuse is 5. Okay. And then you have the tangent, which is the opposite leg over the adjacent leg, 3/4. And then you have the reciprocals. And I was nice enough when I did this test to put them with what they go with, underneath the ones they go with. Okay? Yay, easy problem. Now, find x. So, we're given angle 60. We have the opposite leg and the hypotenuse. So which?
Sine.
Yeah, sine. So the sine of 60 degrees is equal to x over 13. And then you do algebra. So how do I solve it?
Sine 60 times 15.
Multiply by 13 on both sides. So if you don't round correctly, you get it counted off.
Why didn't you? Huh? What do you mean?
It says round to the 5 decimal places.
Oh, shoot.
Okay?
We got a plane.
You're gonna really tell me?
Yeah.
Yes.
gonna be the one thing.
Okay, here we go. Plane's flying. It looks down and it sees the arch. St. Louis Arch. Okay, it's 35,000 feet up. Angle of depression, horizontal line going down, is 22 degrees. What is the distance between the plane and the arch? Meaning, what's the hypotenuse on this right triangle? If that's 22, what is this angle?
68. Huh? Oh, wait. 90 minus.
90 minus 22? 68? Correct? All right, so now what do we have? We have the adjacent leg of 35,000, and we want the hypotenuse. So which trig function is adjacent and hypotenuse? The cosine of 68 degrees is 35,000 over the hypotenuse. Now, how do I solve?
Multiply, and then, divide 35 divided by cosine 68.
Multiply by h, and then divide by the cosine. Very good, Alex. He said it first. Let's see if you can get it right. Move up front.
9,000. Oh, wait.
Oh, I can actually see with those things.
93,430.
That's actually weird.
93,431 feet. Divide that by 5,280 and it's 17.7 miles. It doesn't ask for that, but
Good.
you should be able to do that though. All right, going to the next slide. Everybody ready?
Reference angles.
So actually see the.
It's okay. 5/3. Whoops. Okay. Let's blow this up. Reference angles, 150 degrees. 30 degrees. Raise your hand if you don't know what I'm talking about. Okay, let's pause for a second. What does it take to get to the nearest x-axis? So 100, negative 100. 90 plus 10. Okay, so what is this right here? Yeah, that'd be 80 degrees. Positive. Distance is positive. Okay. 4 pi over 3 we just did. 1 pi over 3 pi over 3, 4 pi over 3. So that's just another pi over 3 right there. Negative 11 pi over 6. Negative. Where's 11 pi over 6? Fourth quadrant. So we're going negative. It's going to be right there. So what is this angle? Pi over 6. Woo! Not necessarily. Okay, now we didn't talk about coterminal angles, so what I want to do is I'm going to make this smaller, and let's do this. Let's put this up here. Coterminal, because it's not on those tests. It's another reason you need to be studying, okay? We don't put everything on every test, so you don't know what's going to be on the test tomorrow. Coterminal means from the original point, like right here. So if I say, what's coterminal with negative pi over 4? Negative pi over 4. So you would go the opposite direction.
Regular pi over?
No, regular pi over 4 would be up there.
Oh, so it's not the opposite.
7 pi over 4 would be coterminal with negative pi over 4. Okay, let's do degrees. Let's do degrees.
What?
Let's do degrees. If I go over to 150 degrees, coterminal, I could go the other direction and still get to that point. Well, how many degrees did I go? Huh?
510.
Yeah, the blue line. 210 negative, because I went down. Negative 210 degrees. Those are coterminal. Okay, and I could go around another 360 and add it to that, and you can do it infinitely many times. Okay?
Okay.
This is lesson 1. Hold on, let's do another one. Make sure you got this. Let's do the pi again. What if I said 7 pi over 6? What's coterminal? So you really do need to know your unit circles really well.
Can't you just take that like? No, never mind. I'm not gonna think of that. I'll go over.
Let me give you a hard one. What if I said 17 pi over 6? What's coterminal with that?
You gotta convert it. Okay. Well, you gotta make it a mixed number.
Mixed number, which is?
5.
2 and 5, 6, isn't it?
Yeah.
Okay, so where are we at?
It's 5.
2 pi and 5 pi over 6 is right there. So again, I can go backwards. And that'd be a negative 7 pi over 6.
I really don't know where you're getting negative.
If you go down, you're going negative.
Okay.
Good.
I don't know where you're getting 7 over 6.
From the unit circle.
Yeah, I still.
Okay, that's another issue. Then you need to come into SRT and let me help you with that. Okay.
Okay.
You have your unit circle page with you?
Yeah.
Why don't you get that out and look at it? Forgot to press record for those. Nice. All right. Let's look at number 5. Is there a 15? Did I miss something here? Nope, right here. 15. So name the quadrant. Sine is the y value. It's negative. X is the cosine, so it's negative. When x is negative and y is negative, where are you? Yeah, there you go. The whole test is not hard. It's the sum of it.
Wait.
What? All right, so let's look at this one. What's the area of a triangle formula when you're given two sides and the included angle?
1/2 AB sin theta. Sorry.
Good. Now fill it all in and calculate it, please.
I'm not smart. I can't even.
Ugly looking 9. Right? Okay.
I got 20.
Good. Now exact value, going backwards, remember.
Yes.
Arc sine and arc tangent go from 0 to pi over 2 and 0 to negative pi over 2. So where is the y value 1/2? 1/2 is the short leg. It's positive. It's the short leg and the long leg. So what pi value is that? Pi over 6. Cosine. Arc cosine goes from 0 to pi. Where's the x value? 1/2. Positive 1/2. That's the short leg.
That's pi over 3.
Yep. And then you got two things to do here. 3/5, that's not on your unit circle, so you have to draw a right triangle. If it's not on your unit circle, it is on the unit circle. It's just not one of those points on the unit circle. So in this case, you have to draw a right triangle. It's positive 3 over positive 5. Cosine is adjacent. Okay, there's your theta, if this is your xy axis there. Adjacent leg is 3, hypotenuse is 5. So what's the other leg? Use Pythagorean theorem if you don't know. So now the sine at theta is 4/5. Opposite over hypotenuse.
Law of science. I like this.
Hmm?
Law of science.
Okay. Law of sines. Let's do this. Let me move this over just a little. So there isn't enough information here So how do we find C? Notice I gave you the angle first. How do you find C? Angle C? 180 minus those other two.
114.
Okay, so 180, what is it?
114.
Okay, so this is 114 degrees here. Now you have enough information. Kelsey, we're here for the law sign? You weren't here for the law cosines. So we were here for law signs. So use opposite. So sine of 114 is to 65 as, and we can do A or B here. We'll do little a. Sine of 46 is to little a. Everybody solve. See if you can do it right. Cross multiply if you don't know what you're doing.
Yeah, 51.
Okay. Get it? Okay, now how do we get little b? Okay, so it's the same type of thing. The sine of 114 is to 65 as the sine of 20 is to little b. See if you all get the right answer. So all this work is what you need to be showing on your paper tomorrow for your test.
So A to C is 24.3.
Yep.
And B to C is 15.
Now law of cosines. Can I go on?
Yeah.
All right, so we want x. What is that? Little a, little b, or little c?
That's little a.
All right, so which formula are we going to use?
A.
The little a formula. So, Kelsey, you're going to need to put this on your formula sheet.
Minus 2B.
So what you need to do is notice that this letter and that letter is always the same. So if you want little b, B would go in those positions, and A and C would be in the other positions. So there's three formulas depending on which side you want or which angle you want. So if I wanted little b, B would go here and big B would go here, and the other two sides, A and C, would go in these positions. If I wanted C, C would go here and big C would go here, and A and B would be in these positions. But make sure you write those down. Okay. All right. So now we just fill out what we've been given. X is A. B is 8. We don't know C, do we? Oh, what are we going to do? Cry because I was supposed to put 4 there.
Wait, 4 was originally supposed to be?
Yeah, I just didn't make it when I originally put it on there. I knew there was another one besides that other one on the page. So, okay. Now this is the trick, Kelsey, when we do these is trying to do this properly without making a mistake. All right, so pause it and... Did you get it right? Awesome. Lots of mistakes yesterday when I first asked them to do it. So if you got it right, that's good. Just take your time. Make sure you don't drop signs. Make sure you don't do some weird thing. Don't do the subtraction before you do the multiplication, that sort of thing.
Can we do that one on part B? Like
Part
the
B.
Law of cosines on the part B sheet?
Love cosines on part B. Yeah, all right, so we're good with